Yeah, hello everybody. Macroeconomics and especially also business cycle, money and investment. And I again want to recommend the talk which will be given by Dr. Jörg Rahn Monday morning. Hopefully I can see somebody of you. I think it will be very interesting. But back again to our lecture, and we were intensively talking about money, what is money, and especially our demand for money. And in general, we derived money demand. Oh no, no, oh, it's working. Yeah. Good. Because sometimes my pen is just moving to the other screen. So I'm writing here and my pen is writing on the other screen. So, motives of holding money. Transaction motives, classical. We need it as a medium of exchange. Precautionary money demand. We are not aware of how the future will be, and therefore we take some safe money in our pocket. And the last one, the speculative motive, that money is our vehicle of investment. And from this, we derived a money demand function dependent on income and interest rates. And the more we earn, the higher should be our money demand. And the higher the interest rate, the lower should be our money demand. And this is the so-called Keynesian money demand function. And on the other side, if we mainly focus on the transaction motive, and behind the focusing on the transaction motive stands the quantity theory of money, where we more or less assume that everything what we want to exchange has to be paid with money, and therefore we assumed that, oops, where is my, here it is, that money amount times velocity of money equals price level times quantity of output. And from this easy equation, if we just rearrange this equation dividing by dividing by v and interpreting then 1 over the velocity as the cash holding coefficient, then we just obtain, if we do not focus on the price level, only a dependence of money demand on income. And this is then the so-called neoclassical money demand function, where we exclude the dependence on interest rates. Well, and taking this quantity theory of money, then we also can ask ourselves, what is the specific dependence between the increase of money and the increase of prices? Because we argued that in the short term, velocity should be more or less constant, and in the short term, the real increase of production of GDP is not zero, is not constant, but we can say that the fluctuations are in their amount less than the fluctuations of price level. Well, from this equation, we actually directly see that there is a positive dependence between price level and money demand. But if we want to do it analytically, we obtain then that the sum of the growth rates of the left side equals the sum of the growth rates of the right side. And how do we obtain this? This we obtain analytically when we are calculating the so-called total differential, which you made hopefully in mathematics. And this we will do just together. So I skip this. Total differential of quantity theory of money equation. So M times V equals P times V. And what we want to obtain is that we want to have these dependence on the growth rates. And for this, we make an analytical trick, which you can also always use when you are interested in growth rates. And in economics, we quite often interested in growth rates, since inflation is a growth rate. Interest rate is a growth rate. You are interested in the growth rate of revenue of your enterprise. You are interested in the growth rate of costs, and so on and so on. And for this, take logs of both sides. So the logarithm. Natural logarithm of both sides means ln of m times v equals, you have to do it the same on the right side, p not v, y. So, and what is, hopefully you remember this, logarithm of x times y of just two numbers. So what is the functional equation of the function logarithm? What can I write for log x times y? Do you know? I think everybody of you did this in school. And I think also everybody of you did this in our math course. So this functional equation is just that this is ln x plus ln y. So, and this is really a nice little thing which we not only use in economics when we want to, in a minute you'll see that with this we quite fast come to the growth rates. This is also a really nice property of the logarithm, because very, very often in economics you have the dependence between variables where you multiply variables. Revenue, P times X. Costs, wages times the amount of labor, and so on and so on. Very, very often we have a connection between our variables where we just multiply these variables. Well, and this multiplication sign, this is quite complicated, so to speak, in quotation marks. What's much easier is if you just have a plus sign. Then we can much easier calculate with things if we just add up them. And this is the nice property of the logarithm, because when you have a dependence where you multiply variables, then this just means when you take logs of your function that all the multiplication vanishes and you can just look at the sum of these variables. And then, I don't know if you had made these in statistics, then it's quite easy to make linear regressions. Then quantitative analysis becomes much easier. And therefore, this is very, very often done when you not only want to think theoretically about things, but if you want to start quantitative analysis, because with the sums you can much easier calculate than with the multiplication. Okay, so here, coming back to our calculation, this means we can write ln amount of money times log of velocity equals log of prices plus log of production. So, and now total differential. What is the total differential? We just want now to see what happens to our equation if we simultaneously vary all variables. What is the dependence if the amount of money, the velocity of money, prices, and production change simultaneously? Well, and this is in general almost always the case, that all your variables change simultaneously. In the analysis, when we do partial analysis, then we always just assume that something is constant. Take, for example, if you take a cost function, then you divide this cost function in fixed costs and variable costs. But of course, in general, also your fixed costs are in the long run also changing. And therefore, in general, we are interested what happens if all variables change at the same time. And for this, we can say the total differential is something like a general derivation of your function. In mathematics or in school, you mainly looked at, you have just a function of x, and then you looked at f prime of x. But now we look at the simultaneous change of every variable, and this is written with the small letter d as the variation. Maybe you have also written in school that f prime equals df to dx. So this just means the same. So what we want to do is then taking these change with all variables at the same time. So d ln m plus d ln v equals d ln p plus d ln y. And for this, we have to start with that we have to derive the function ln m with respect to the amount of money. And for this, we have to know if f of x equals ln of x what is f prime of x. So the first derivative of the logarithm. What is the first derivative of log, or the natural log we take here? Yep. Yep. So this is, so to speak, a general derivative of your function. Because in economics, of course, we almost every time we do not have only one variable to change, we have many variables which are changing. Yep. Yes, definitely right. Great. So I always say there are some derivatives you should know, but not many. You should know what is the first derivative of x squared, x to the power of 5, or square root of x. So functions you need is f of x equals x squared, square root of x, exponential function ln x, or in general x to alpha, I would say, and maybe sometimes also 1 over x. If you take these 5 or 6 functions, then you are done in economics. We do not use more functions than this. And from these functions, you then should also know the first derivative, because we are always optimizing in economics, and optimizing means analytically taking the first derivative and setting this first derivative to 0. This is always the same concept. Okay, so then we know that this becomes 1 over m times what is changing? Well, the money amount here. So dm plus, and here we have always the same function. It's a very, very easy equation. So 1 over v times dv equals 1 over p times dp plus 1 over y times dy. Well, and if you do not take here the limit, the differential d, then quite often you interpret this just as the change of the variables. Change of the variables, and just writing it in another way, 1 over m dv over v equals p dp over p plus dy over y. Well, and this is change over the absolute value is nothing else but the definition of growth rates. And this is a nice little thing. If you take the total differential of the log of your equation, you just directly end up with the dependence of the growth rates of your equation. And this can also always be done. Well, and now with this dependence, we go to our interpretation of the numbers. Well, we just again assume that V is constant, the velocity. If the velocity is constant, then we have no change in velocity. So the change dv or delta v is equal to 0, and this term just vanishes. And what we then have is that we just obtain dp over p is inflation this is our real growth rate, real growth of GDP, and with, of course, this is the growth rate of money. No, there we are here. And this then just means inflation equals growth rate of money minus real GDP growth rate. Well, and then we can say GDP growth, it's not very large, but there is some, hopefully, growth in GDP. Remember the magic square, roughly 1, 2, maybe 3% per year. And this then means that if we do not want to have a deflation, remember our target of 2% inflation, that in usual times we at least need some growth in the amount of money, because otherwise we won't reach our inflation target of 2%. So roughly we can say for developed countries, growth rate of GDP maybe 2%, inflation target also 2%, then growth rate of money of 4-5% is what we need. But we can say in the long run, if we do not always push our economy, then in the long run, of course, the real growth rate is dependent on our technological progress, and one main part of technological progress is, of course, smart people, and these are you. So if you are smart, then in the long run, the cake in our country will be larger. And we count on you. But on the other hand, this then translates from this equation that if we externally, like in the situation right now, we push the increase of money, then we end up in a scenario of high inflation rates. From this theory, of course. And this is then, again, we can summarize this with the famous sentence of Milton Friedman: inflation is always and everywhere a monetary phenomenon. Because pushing money increase, then we, of course, we have some, hopefully, some real growth rate. But this is in the long run. This highly depends on the framework of our society, of our economy. And if we push money increase further and further, then we just end up with inflation. Well, and in general, this then means if we explicitly assume that this theory, quantity theory of money, that this holds, or as Milton Friedman said, this is just a balance equation. Then actually we have a decoupling between real variables and nominal variables. Because then money is nothing more than a whale. Because this is only the medium of exchange. And this decoupling is called the classical dichotomy. And this then means we cannot push our economy with just increasing the money. And there is some very famous thought experiment written down in the Inquiry of the Wealth of Nations. Who has written this book? Well, the godfather of economics, Adam Smith. And he made the following thought experiment. In Britain, you have red pennies, or the color of the pennies is red. And then he said, well, let's think about overnight, all our pennies become green. And the king, for example, claims that all green pennies have the value of 2 red pennies. What happens in our economy? Everybody has now the double income. Remember the money demand? We said the higher the income, the more transactions. The more money I have in my pocket, walking downtown, the more I will buy. So now everybody has double income. This would be the first thing we think about. Everybody is twice as rich as before, so we are pushing with this economy. But then we have to think further. Keep in mind this quantity theory of money. Now, of course, everybody has now not 1,000 pounds, but 2,000 pounds. But everybody, also the suppliers know that everybody has the double amount of income. What is the bakery then doing? Well, just increasing the price of bread. He knows the guy who is stepping inside this morning has not 1,000 pounds, he has 2,000 pounds. So I just sell my bread not for 2 pounds, but for 4 pounds. Because I definitely know that he can afford it. And so the money increase, the doubling the money, just means we have a doubling in the prices. And this is called the neutrality of money. So money is only this medium of exchange. And increase of money does not have any impact on the real variables. Well, and there we have much research about this thing. And there actually we find in the long run that this is more or less true. But in the short run again, we said that we quite often act a bit myopic. Myopic means, what is it in English? Short seeing, I would say, something like this. So that we sometimes only see, well, oh, I have the double amount of money. I really start to buy more. And this is quite often then the discrepancy between the economists. Should I do something as a central bank in monetary policy? Some guys argue, well, this really functions if we increase the money, because then we obtain at least a short push in the economy, and this will help. And the classical economist, he said, well, no, don't do it, because this only means that prices increase and high inflation rates are really bad for your economy. But in practice, we actually see both. And if we take historical data, then at least for the long run, we can really say that money is more or less neutral, and sometimes the politicians won't see it, that it is like this. Okay, so with this, we end the part where we are talking from a theoretical point of view, what is money, where comes money demand from, and what different schools of thought we have when we are talking about money. And now we want to go to the money creation process. Well, and there, of course, we talked about fiat money. Where comes the money from? We just organized it like this, that in, so to speak, in the first part, the money comes from the central bank. So let's have a look at the balance sheet of the central bank, and this is then more or less the monetary base, the balance sheet of the central bank. What do we have at the central bank? Well, it is, of course, a public institution, but it is also, of course, just a bank, and therefore we just look at the assets and the liabilities. And at the assets, of course, we have the holdings of foreign reserves. If you go to the ECB, then the ECB, of course, holds US dollar, holds British pounds, holds a Swiss franc, and so on. Then they give, of course, credit to the domestic banking sector, and then we have there some other assets. But these are the two main positions on the asset side. On the liability, there is, of course, our cash money, the currency in circulation. Then, from the regulatory side, we have deposits of the domestic banking sector. This we will do in a minute. So if a private bank obtains, let's say, 1 million of deposits from some private agents, they are not allowed to give credits of an amount of 1 million euros. They have to hold some amount back, and this minimum reserve right now is 1%. And also what we have in the actual situation is the so-called deposit facility. What is the deposit facility? This is the possibility for the private banking sector at any time to make a deposit at the central bank. We will talk about in more detail later on about this deposit facility. And before the financial crisis, this deposit facility was more or less irrelevant, because the interest rate you get here for this making this deposit is always less than the interest rate you get from the private banking sector. But after insolvency of large banks, the private banking sector or the private bank didn't trust each other anymore in that kind as before the financial crisis, and though quite often they went just to the central banks and put their money at the central bank. So in this deposit facility right now, we find an amount of trillions of euros. And then we have also some other liability. So what then changes our money amount is then, of course, if we increase or decrease our balance sheet. And this is then, of course, mainly done if we buy or sell foreign currencies. So this is then just changing in a very easy way the monetary base. But we saw from coming from M1 to M2, M3, we define much more than central bank money as money in general. And how does this money creation functions? This functions via the commercial bank. So the commercial banks, they obtain deposits from their customers. And then I said they are not allowed to give 100% of these deposits as credits, but partially they will lend it to other private customers. And then in general, the next private customer will not have his account at the same bank, the same bank. So what happens if he obtains credit? This credit is transferred to his account at his bank. And then we talked about if this is the account which is connected to his bank card, to his credit card, then he can use this amount of his account just to buy things. So this is then, per definition, money. So then the other bank, the second bank, has a new deposit. What is this bank doing with this deposit? Giving credits partially to a third agent, to a third consumer, and so on and so on. And this means that every new side deposit, definition from M2 and M3, we made, that all these new deposits have the character of money. But of course, this process is limited by the required minimum reserve. I said this is actually right now at 1%. But we see in practice that banks hold a bit more than these 1%. Because again, because of the risk in the future. And also in general, we are right now aware of the possibility of bank runs, and this probability, you know, I made a short video. And now we want to analyze this money creation process here in more detail. So let's start. Let's do it like this, that I have a bit more space to write. So let's start with my million. The first commercial bank, CB1, has 1 million euros deposit, and what we have is a minimum reserve ratio of 10%. So now CB1 gives credit of how much, if he has a reserve rate of 10%, how much credit this bank can give to the next agent. If I'm holding 10%, then I can give how much to the next agent? Yep, 90%. And this is when, if we start with 1,900,000, then gives credit of 900,000 to a private person or agent. This private person has a banking account at the next commercial bank. So CB2, or to a private person with an account at commercial bank 2. Then at commercial bank 2 obtains deposits of 900,000 euros. What is this commercial bank doing with the 900,000? Well, CB2 gives credit, again, all, let's say all commercial banks have a reserve rate of R equals 10%. How much credits can I give to the next agent? Yes. So, yep, euros, yeah. 1,000 euros to the next private person and with account at Central Bank 3. And let's take one last step. Then CB3 3 obtains deposits of how much? Again, 90% of 810,000. Yep. Did I do them? So CB2 obtains deposits of 900,000. Okay. Oh, yeah. Yeah, you're totally right. Yeah. One Central Bank 2 gets 900, and then we have here contains 110,000 euros, and now CB3 can give this. I want to do can give credit of, and now we need the next one. Sorry. Yes, 729,000 euros. Well, and so on and so on and so on. And now we know, since every credit becomes a deposit at the next bank, we have to sum up 1,900,000, 800,000, 729,000. So then total money in the financial system is 1 million plus 900,000 plus 810,000 plus 729. And this process can go on, it can go on and on. Just theoretically to infinity. So what will be then the total amount of money? We add up an infinite number of money amounts. Will this be an infinite total money amount? Well, let me write these numbers in just another way. Maybe you see this then. Here, how did we get these 900,000? This was 90% times 1 million. How did we get the 810? This was 90% of 900,000. So this is 90% times 90% of 1 million. Here, 729 is then 90% of 1 million times 90% times 90%. So 90% to the power of 3. So in every number there we see that inside this number is hidden the 1 million. So I can take out of brackets 1 million. Then I can write 1 million equals, and then I write here 1, because the first number is 1 million itself. This would be this. Here I have just 1 million times 0.9. Here I have 0.9 times 0.9, so 0.9 squared, plus 0.9 to the power of 3, and so on. Does anybody recognize this series? This series has a specific name. And hopefully in your financial part of your mathematics course you have seen something like this. Yep. And maybe we have like discounted. Yes. Yeah. It has something to do with, you find this series also when you calculate annuities. When you are discounting, you made something like 1 over 1 plus I, 1 over 1 plus I squared, 1 over 1 plus I to the power of 3. This looks quite the same structure as this. And did you also introduce a name for this? This is the so-called geometric series. So, and mathematically, you can show that although you are adding up an infinite number, this doesn't become a total number of infinity. And this you can, did I have white chalk here? So let me see, where did I, oh, this is, focus is also, yep. This here is the geometric series, yeah, in the brackets. Only red chalk, or what I had here, white chalk. Let's think that your reserve requirement would be 50%. Then we could say our 1 million is maybe represented by just a square. This should be our 1 million. So what is the amount of credit with the first bank if my reserve requirement is 50%? If we want to represent this graphically, this is just plus 1/2 of this square. 50% of this. So the total one would be CV1, the next one is CV2. How much deposits obtains the third bank? 50% of the amount of the second bank. So again, we halve it. This is CV3. How much obtained the fourth bank? Again, half of it. What is then the additional area you obtain in total? You are going further and always half and half and half. Can you think of this graphically? If we go on, what would be if we add up all areas which we obtain here? Do we end up at infinity? No, but again, an additional total square which we already had, or going further and further and further, and so on and so on and so on. So then this adds up to 2 million. We started with the total square and we add up with a second square. Well, and if you take 50% or 10% conceptually, this of course has to be the same. So this number here adds up then also to a number which is not infinity. And in general, well, I think I create a new slide. Or here I have this empty slide. Here is it. So we were at 1 million times 1 times 0.9 times 0.9 squared, 0.9 to the power of 3, and so on. For this 1, we can also write as 0.9 to the power of 0. This hopefully you also know. This is mathematically defined, that any number to the power of 0 is defined as 1. And from this, we know in general, we can say this is then the sum of q to the power of n starting from 0 to infinity. This is our geometric series, and from this we can generally show, we can prove that this equals 1 over 1 minus q, but of course we have to assume that the absolute value of q is smaller than 1. So this will be then 1 over 1 minus 0.9 times 1 million. So we get then 1 million times 1 over 0.1, and this is of course then 10 million. So we have then via our commercial banks, if the reserve rate is 10%, the money creation process that we start with 1 million at the first bank, and via this money creation process, we obtain in the end then the 10th amount of this starting money, namely in our example then 10 million. And since we are going through to from the first bank to the second, to the third, to the fourth, and so on, we call this a multiplier process, because through handing all these credits through the banking sector is multiplying the starting amount of money. And these multiplier effects we also analyze quite often in economics. When we look later on at our theoretical models, there we will conceptually also look what happens if we increase, for example, public spending. Somebody has to pay all the money which is handed now for energy to the private households. So you can just argue, if you give this money today to ourselves, so our children have to pay it back tomorrow. So don't do it today. But we think that, or we hope that through handing out these public money, there's also a multiplier process initiated. That giving us today some money means that more money is created tomorrow, so that our children or you do not, or that you are really can pay this money back, which we give today in our society. Well, and then in general, this reserve requirement of 10% in our example, we can have a look at it in a general way. So in general, we have then our starting amount of money M0 times 1 minus our reserve requirement to the power of 0 plus 1 minus the reserve requirement to the power of 1 minus r power of 2, and so on. And this will be M0 times 1 over 1 minus 1 minus r. Then the 1 cancels, of course. Then you have minus brackets, minus minus is plus. So 1 over the reserve requirement is this multiplier in your system during the money creation process. So this is then called the money multiplier. So, and this, of course, also means decreasing the reserve requirement in your system means pushing the amount of money. And actually, this we also have done. I think it was 2015. There we decreased the minimum reserve rate from 2% to 1%. And also this was monetary policy, expanding the money amount in our economy. So here, because my handwriting is so awkward, you have it also written down. Well, actually, this has to be a large R here. So, and 1 over R is then called the money multiplier. So we have some time. So today we can start with monetary policy in general. There we repeat, we had it at the magic square. What is the general aim of monetary policy in the Eurozone? That we obtain an inflation rate of 2% in the medium term. This is measured via the consumer price index, and well, since it's the medium run, there are times allowed where we are higher than 2% and lower than 2%, and the evaluation of the deviation from our target of 2% should be valued symmetrically. Why is this also important? Well, this has changed in 2020 that we made this new definition. And before that, we had an aim where we also said 2%, but close but lower. So there we had an unsymmetric aim where we said, well, please not more than 2%. And this has changed into a new aim where we said, well, we also allow times of 3 or 4%. So, and what are now the practical instruments in order to reach this 2% inflation rates? There we have at first the so-called main refinancing operations. What are these main refinancing operations? Well, the commercial banks have to obtain somehow the central bank money, because in our system they need also always to have a specific amount of central bank money, and this amount of money they obtain for an interest rate, and the interest rate of this main refinancing operations, this is then, the central interest rate of our central bank. So if we are talking about central banks will in the future, in the next days, increase interest rates, which interest rate is then maintained? This is the interest rate of the main refinancing operations. So this is the key interest rate of the central bank. And then I already talked about this. We have in Europe two other important interest rates. And the one is the so-called deposit facility. So this deposit facility is the possibility for the commercial banks, so to speak, if they have some money left over, what should I do with this money? Then they were always allowed to put this money as a deposit, or they are always allowed to put this money as a deposit at the central bank. But for this deposit, they obtain a lower interest rate than the interest rate of the main refinancing operation. Well, then it is possible that we have the other way around, that a commercial bank has made a miscalculation and very shortly they need central bank money. Well, and for this we have the so-called marginal lending facility. So when a commercial bank is in trouble and from the regulatory requirements, they need today central bank money, then they can go at any time to the central bank and they get central bank money, but for an interest rate which is larger than the interest rate of main refinancing operations. So let's say that this is IM. Let's call this ID. This would be always lower than the interest rate of the main refinancing operation, and this marginal lending we will call L. IL. This is always larger than the interest rate of the main refinancing operations. Well, and actually, before our new times, before financial crisis, before Euro crisis, before Corona crisis, these two facilities, they were almost not important because all the commercial banks, they handed, if they needed money or if they want to make a deposit, they could always do it at another private bank, and there the conditions were always better than the conditions of the central bank. And then with the financial crisis, everything changed because the commercial banks had also in mind, well, the other bank could also be not there anymore at the next day. And therefore, it's better for me to take the to take the worst conditions, but I know, or the probability that the central bank will be not there tomorrow, this is much less than the other commercial bank, and therefore I make my deposit at the central bank, or if the other commercial banks think that I will not be tomorrow there, then of course I don't get money from them, and therefore quite often during this time these banks had to go to the central bank. And the last one is the minimum reserve. We talked already about this, and this are then summarized as the so-called classical monetary instruments, but in, let's say, normal times, or maybe we already have now a new normal, the main classical instruments were the main refinancing operations with the key interest rate and the minimum reserve, because the private banking sector didn't really use these two facilities. And now let's focus on these key interest rates. There now we assume that this is more or less steering the level of interest rate in our economy. And now we can think of, well, how can now in practice influence the central bank the interest rate level in the whole economy? And for this, well, we cannot directly. We cannot say now you have privately to interchange your deposits in the private sector with my key interest rate. But the central banks, they have a look at the short-term private banking interest rate. And this is the so-called euro for the Eurozone, the so-called euro short-term interest rate. What is this? This is the overnight interest rate. And for this interest rate, the private banks change their deposits between each other. And the central bank, the European Central Bank, tries to steer this short-term interest rate. Because, of course, this is highly coupled on the key interest rate, because from regulatory requirements, I always need central bank money, and therefore this is highly dependent, or the euro short-term interest rate is highly dependent on the key interest rate of the main refinancing operations of the certain central bank. Well, let's now assume that we more or less can steer this short-term interest rate one-to-one. What happens then? Of course, we have also longer-term investments, not only overnight. This means if this short-term interest rate is going down because the central bank has decreased the key interest rate, what happens? We just look at the financial markets and we see that longer-term investments, half a year, 1 year, 2 years, that there we obtain still a higher interest rate, because this longer-term interest rates the central bank cannot directly steer. So we are starting to shift our investments to longer-term investments. What does this mean in the markets of the longer-term investments? Higher demand. Of course, prices of these investments will increase. And what this means, if I have to buy at a higher price, then of course my interest rate, my yield of these longer-term investments will decrease. So in practice, over time, we will have an adjustment also in the longer-term investments. So then indirectly, if key interest rates at first, we have there a cut, so key interest rate goes down. This means short interest rate goes more or less directly down, and then indirectly because of this market process, everybody is shifting his investments to longer term investments. Also indirectly, longer term yields will decrease. But of course, this process takes always some time, and therefore, in general, we won't see that you have for all maturities the same interest rate, but in general, we will see that the interest rate for investments with different maturity will differ. And these difference, if we plot this afterwards, so if we plot interest rate versus maturity, then in general, later on, we will talk about that an increasing pattern is called a normal dependence, that this dependence of interest rates on maturity is called the yield curve. So still we are only in the financial markets, and here we are in macroeconomics. So we also want to know how works changing interest rates by the central bank within our economy as a whole, within real variables of our economy. And this we will analyze in a classical way. So now we skip these practical issues that we can only steer the short-term interest rates. Now we say, well, over time, we have a shift in general in the interest rates in our financial markets. And now we assume, okay, it is possible for the central bank to decrease or increase the interest rate level in general in the economy. So again, we say that the main key interest rates will be cut, so going down. What does this mean? Credits become cheaper. Because the interest rate is just the price of the credit. If credits become cheaper, what can I do? I can consume via a credit. Or in general, larger investments will be done via a credit. If this credit is cheaper, then a usual impact of these cheaper prices will be that we expand credit-based investment and consumption. So, and then, of course, we are, so to speak, in our market, demand function, supply function, because of the external change via the central bank. Demand is in general for goods and services is in general increasing, so we will have a shift of the demand curve to the right because of the decrease of the interest rates. And this then will have the effect that production will increase, so the utilization of our production factors will increase. So this is a possibility to push economic growth. But now think of the business cycle. We cannot push and push and push on and on and on because we have our production potential. And if we come to the limit of the capacity of our economy, then profits cannot increase anymore. They will start to stagnate. And even in such a situation, the future calculations of our interest rate enterprises, the forecasts will maybe then say, well, right now we are in the peak, but I think in the business cycle, the next phase is coming, the decrease is coming, the next crisis is coming. So maybe I expect that my profits will fall. If I'm still pushing or try to push my economy via low interest rates, this cannot increase investment anymore because I'm already, other this not has to see in connection with, I'm already producing at the limit of my economy, at the limit of capacity. And then we are more or less come in this scenario of quantity theory of money is holding, and then the increasing demand is more or less only have the impact that prices are increasing. So in this case, we here, let's say, oops. Here we have maybe at first, if we look at a market, a small effect on prices. And in general, if we model something like an aggregate supply function, then we see that the aggregate supply in an economy from a macroeconomic point of view has a pattern like this, that this supply function becomes steeper and steeper and steeper. And if we more or less start with a demand function at the slow part of the aggregate supply function, then this pushing works. But if we go further and further and we are just in this area, then we see the next push will more or less only push prices. And this is meant then that in the end, we are only creating inflation. And this is then the task of good economic advisors, more or less. Where are we in our situations? Are we in the situation on the left side? Then pushing the economy is maybe via low interest rates is maybe a good idea. If we are in the situation where we are on the right side of this picture here, if we are here, then of course it will be a bad idea to still push via low interest rates our economy. Okay, and then the effect via the indirect effect via stock markets we will do next week. Thank you.